So we will make a detailed recap of interfaces. So we'll start from the interfaces again. So what is interfaces? We had seen abstract classes. So an abstract class, what does it mean? It's not a full class, which means that it might have some methods that is not implemented yet. So in an abstract class, we had some functions that is not implemented, but we leave it for the classes that will extend that abstract class, and they will, and then we will force them to implement it. So, and because of that, we will be never able to create an instance of an abstract class. Like for an abstract class, we had given this example, like if we have an e-commerce platform, like an item that we are selling, might be an abstract class as an item, because we don't sell item. Like what is an item in real life? So we sell books, products, and so on and so. We sell books, smartwatches, tables, and very specific things, but we don't sell something called item. It's too specific, too abstract. So that was the abstract class in which we might have some unimplemented methods, but also there might be some implemented methods in an abstract class. And there is always an inheritance relationship between abstract classes and the full classes. Now, why did I mention it? Because now we'll go to the interface, which is actually a little bit more extreme version of abstract classes in terms of implementation of methods. And also there's a difference between inheritance. So what is this? And when I'm talking about interfaces now, it's a little bit challenging to explain what is an interface in Java. The reason is that Java keeps changing what is an interface in its variants. So when I was first learned interfaces, in that one, an interface had no implemented methods, but now it allows us to do that. So there's also this kind of a challenge, but we will cover then, we will explain the latest version of interfaces, okay? So first, in an interface, you might think it as a bit more extreme version of abstract class, in which we don't implement any method at all. In most of the case, I will rephrase this word later on, but we just define, okay, we have these methods, like this is its name, this is parameters, this is what it returns, and that's it. So, but then what happens is, a class implements it. Now there's also a difference. A class implements an interface, not extends, so that we will, so there's no, and then I will give an example for this, so that what happens is, if a class implements an interface, it forces them to implement all of them. I will give an example for this now. Let's go with, let's open our Eclipse. And we had this example, if you remember. Let's say that we have this interface, payable, okay? So here is this syntax. We don't say class. It's not a class. It's not an object. It is an interface. So we use this interface and as a keyword, and then a name, and then between the curly brackets, I only define the functions that needs to be implemented. So I didn't define anything about how to pay and so on. I can define some, I don't know, any, let's say that get calculate total amount, maybe, amount to pay. And then, like an abstract methods, I define it here, but as you note that I didn't put the abstract keyword here. It's not, I don't put it, I just say public boolean, the function name, and the parameters that it takes, and that's it. And maybe I can define some more other functions that I need to implement. Then why am I doing it? Well, let's say that a build function, a build class, okay? So I might have a build class first. I will first remove this part. And I might have also, let's say, an employee. Normally, I should write them in different Java files, but I just want them to put in one place so that you can see both. That's why I'm doing this, okay? Normally, this is not a good programming way to put them in one single file, but I'm just doing it to show them at one place. Now, a bill is not an employee. An employee is not a bill, of course. There is no inheritance relationship between them, but they have a common point. I could pay the salary of an employee and I can pay the bill. So they're not the same objects, they are not same type, but they have a common point. I can all pay both of them. They're all payable. So let's say that I am running a company, I need to pay the bills, I need to pay them to my employees. So what I need is so at the end of each month, I need to calculate how much I need to pay also. So what I might do is I can create an array list in which I put all my payable objects so that I can just iterate over that list and calculate my total payment amount that I need to pay. But the problem is that, again, they are not the same types. A bill is not an employee. So but I know that they have a common point. So what I will do is, for those cases, I know that there is no inheritance relationship, but they have a common point. I implement this interface, payable. Okay? Then I know that, okay, each one should be payable, and also there's I need to calculate the amount. So I implemented this interface. Then what I need to do is, I will not write extends payable. That would be incorrect because this is an interface. This is not an inheritance relationship. What we need to write is implements. And also I will do it for the same thing for the employee. An employee also implements a payable. When I do it, what I mean is, know that I'm getting now errors in both classes, because when I said, okay, employee implements payable, it means that, okay, I give a promise to Java saying that, okay, this employee and the bill classes will implement every method not implemented in this interface. So if I don't implement it, Java will make it a noise, will make a problem, and will not run my program at all. So it is forcing me to implement those things. So what I will do is then, okay, I need to implement it. Like for whatever I need to do for those operations, let's say then whether I paid it all right. Of course the content there should be some more operations, but it's not related to our topic, so I will move on. And then I also need to do it for also employee. Maybe it will return true, whatever. But it's still giving the noise, like, because I'm still getting an error. The reason is that there are two functions I need to implement. Like, even one implementation will not be enough. I have to implement everything there. So that's why I need to also implement this thing in both. Once I do that, it will, let's say that it is 0. Of course, it should not be, but I mean, there should be some operations, but the content of the method is not related to us. Now I'm not getting an error because I keep my promise now. I said that I will implement it, and I implemented this part. This is the interface. Now, it has two advantages. First, I can make a connection between items that are by inheritance, they have no relationship. So what I mean is, like, let me go to my main method here. And in that one, let me create an array list in which I will keep payable items there. Okay? So, payable objects maybe. and then I will create a new array list for it. And then in that one, what I can do is now I can group all these items in one list. Like maybe I have an employee. And I can have also a bill to pay. And then, assuming that they are filled the other attributes or so, of course, currently these are very extremely simple objects, but let's say that it is filled. It's not what I'm trying to show. Then what I can do is, well, I can say, okay, the total amount that I need to pay. Of course, I need to first add it to my payable object, sorry. I need to add it to my E1. I can edit this. I can add also my bill. And then in a payable item in my objects, I can basically calculate this total amount by using this calculate amount part. So what I did is, although these objects are not inherently related, I could put them in one list, and then I could use it in my operations because they have a common point, and through the polymorphism. Now normally this payable object is, when you look at it, it is not implemented, but through the polymorphism, now these becomes actually polymorphic objects, so that I can run them. And you might say, okay, can I create a payable object, like, because I put it as a list? Well, the answer is no. This is an interface. This is not like we do with the abstract objects. Like in the abstract classes, we can create an array list of abstract classes, and then we can use them. But here, no, we cannot. But we cannot create an instance of an abstract classes. Same for here. We cannot create an payable object instance. It is because it's not even a class. It's not even an object. It is just an interface. But I can use them and I can group them in a list. All right, so this is one option, that one advantage of it. The other one is, let's say that I'm a team leader of a software project. So there are many developers running in the same project, and then I'm trying to organize the whole thing, like define all the classes and functions because they are related to each other. Some classes will use the functions in other classes. They are so interconnected. So some person should decide, okay, what is our function names? What are their parameters? What value should they return? So that I'm the one, for instance, as a team leader, I'm the one. But the thing is that, okay, I cannot implement all of them, but at least I know that, okay, we need a payable list. Each employee should be payable. Or we also have bills, so they should also have the same function. So, but then what I will do is, okay, I don't know, I didn't implement it yet. I will give this to the software developer. Okay, this is the employee. It implements payable. Okay, then I don't need to follow up whether he really implemented those functions or not. It will force that. Java will force it actually, because I will just prepare the interface. Okay, in this one I need this and these functions. That's it. I will not feel implemented by myself, but then I will give the employee that, okay, this is the class that you need to fill. It's an employee and it implements payable. Then it will force them to implement it. So that will also make me easier to manage the project. And also, the other one is, the third option is, let's say that you are checking a library that okay, we have this employee class. Like you are a developer and you want to see the library and you will use it accordingly. And then you said, okay, it has a payable function. Okay. Then what you will be confident that, okay, I don't know how it is implemented. I don't know what this class is all about. But I know that if it is implements payable, then it should have all these functions, so I can calculate the amount and so on. So again, as a developer then, if I know that if a class implements a certain interface, I don't need to look at how it is implemented and so on. But or I don't need to check, okay, what is the function name of this? Does it have that function? I will be sure that, okay, it has this calculate amount function. It has this pay function, definitely. There's no way for it. So this is also another advantage of it. We see it in many, there are some popular interfaces in Java. Like, for instance, I will show two things actually here. Comparable interface, this is a very common, famous interface. Well, what it does is it has only a single function. If you go to that, yeah, this is that function definition. It only has this public int compared to. That's it. So why is it useful? Well, let me go back to here. When I see that, okay, a class that implements comparable, okay, it has a function compared to it, so that I can use it to compare this object to other cases. As a software developer, I don't know how this build class will be compared. I don't care. I know that it has this compare to function, which returns integer. So if they are same, it will return 0. If one is greater, it will return 1. Otherwise, -1. Okay, then that information is enough for me to use this function. I don't need any other thing else. So when I see this, okay, this class implements it. Okay, that's perfect. Then I'm sure that it has this function. So it has the advantage of in interfaces. And also here you see one more thing. In an inheritance relationship, let me show it in another one, like the book object, for instance, that we had defined. I know we didn't define here. Let's say the car toy object that we had defined before. So when we say extends, we said that, okay, it can only have one parent. It extends toy. It cannot extend another classes. In Java, this is not possible. In other languages, it is. But in Java, you can only have one parent, not more than one. But when you are talking about the interfaces, you can have multiple interfaces. Like a class can implement more than one interface at the same time. Then what should be done? Well, for instance, in this class, it is saying that, okay, it implements payable. It needs to implement all the payable functions. And also, it implements comparable. So then it should also implement the functions that is defined, that is in the comparable. So that's why I'm getting an error here, because I only implemented these functions coming from the payable, but not the one coming from the comparable. Like if you are using Eclipse, actually, it will give you that message. It says unimplemented methods, and even if you just click add unimplemented methods, it will automatically put the function that you have to implement compared to function. Now it will stop complaining about it. So basically, in short, if the class is implementing multiple interfaces, then it has to implement all the functions that is defined in those interfaces. Any questions so far?
Can we extend the superclass and implement interfaces at the same time?
Yes. Yeah, definitely. So if we have an employee,
extending a company, the company has employees.
and then maybe an employee. We might have another class which is, I don't know, let's say manager, which extends employee. Okay. Then and then it can also implement payable. Yes. And if you want, you can also put compare to whatever comparable functions, all of them. Then you have to put all of these functions, add them here. All right. Any questions so far? So let me go back to my slides to check if I miss anything here. Nope, not here. Not here. This is the same example, so that's why I'm skipping. Well, this is just one more example if you would like to see. So let's say we have this interface animal in which we have these functions, animal, sound, and sleep. And then we have this cat class which implements animal. So then we have to define this animal sound function and the sleep function. And then we can call it and use this one. So this is the basic simple example. And in a class diagram, so we also put this interface information. How do we represent that? Okay, this is an interface with those dashed lines. Like if it is not a dashed line, like solid line square, then it means that it's a class. But if it has these dashed lines, then it means that it is just an interface. It's not a class. So that, and how do you show this implements relationship? Again with this arrow sign, but again with those dashed lines. It means that, okay, my class implements my interface.
So if the line was a straight line, it would be my class extends my
Yes. All right, and let me see. Oh, I should, yeah. And another difference between abstract class and the interface is that in an abstract class, I can define attributes. And they can be constant, static, not static, anything it can be. But when we are talking about interfaces, they have to be always final and constant. So what what does it mean is that in a payable amount, let's say in an interface, I can define a function, any attribute, sorry. Let's say that integer, or maybe we have some tags, let's say. Okay, I didn't define it. As you can see, I'm getting an error because this is not an attribute. Like that in an abstract class I would. And let's say that some number, whatever it is. Now note that this is the Eclipse already put it in italics and with a bold font. What it means is, like, even though I didn't say anything about whether it is constant, whether or not, or whether it is static or not, well, we see this bold and italic when, let's say that in this build function, build class, let me also define it here, and then you check the font and the style of it. It's not bold, it's not italic. Why is that? Well, it has, because this, if I made it, sorry. Oops, some Turkish letters. So note that when I put this static, it made it italic. And note that when I make it final, it made it bold. So from an Eclipse perspective, if it is bold and italic, it means that it is static and final. So here I didn't put any of it, but it is bold and static, which means bold and italic, which means that actually, even though you don't put it or not, every variable that you define in an interface is actually final and static. You cannot change it, and it is a static one. So what does it mean to have a static function? Well, when I go to my main method, for instance, I can I can immediately access this constant variable and use it in my applications. So there is no, I can just use it. I don't need, since it is static, I don't need to create its instance, and and I cannot create an instance of an interface. So that's why I can just use it as here, as like this. All right. Now I will ask you one tricky question. Why am I getting an error? So I said in this interface, this is Boolean pay. I didn't put the public. This is what I want you to notice. And then I just put the Boolean pay also here. But now what you are noticing is that I'm getting an error here. You need to merge two information, one from inheritance, and the other one is just, we will see later on. But we are getting an error here. Why it might be? I'm already implementing this function. I didn't change its syntax. It's still returning Boolean. And this is Boolean pay, this is Boolean pay, same thing. Any educated guess?
It should have something to do with the access modifier, because but they're both default, so it doesn't make sense. It's default by
Yes,
default.
it is about access modifier. And when I change this to public, it will stop complaining about it. The reason is that in an interface, actually you don't need to say that it is public, because whatever you define, it will be public. You don't need to, by default, it is public. So there is no default access modifier for the interfaces. It is always public. That's why, even though I didn't put anything about it's public or not here, Java says, okay, you didn't put it, but it is public. So that's why when I delete this, even though they look same, okay, this is Boolean pay, this is Boolean pay, then you might say that, okay, Java, are you crazy? Why are you complaining about it? Don't be so, can you just relax and run it? But it will say that no, this is, one of them is final, the other, sorry, public, the other one is default. You are reducing the accessibility of a function, and this is not allowed in inheritance. If you remember, if you want to override a function, you cannot reduce its accessibility. You can only increase it. So that's why it gives us an error here. So when dealing with the interfaces, we know that they are all public, all methods and the variables. And for the variables, they are final and static. Any questions so far? Let's give 1 minute break for attendance.